This is lesson 5 of the chemical bonding storyline. This is for high school chemistry. This is a very exciting lesson because during this lesson, students really get to model the breaking of chemical bonds using a special setup that I designed. The chemical bonding storyline is officially titled, "Why Do Some Things Get Colder or Hotter When They React?" Check the Stunning Storyline playlist to watch all the various videos that I've created about this storyline. I have chronicled all the previous lessons so far, including lessons 1, 2, 3, 4, and now we've reached lesson 5. The central question of lesson 5 is, are magnets a good model for the connection between particles? The focus is on the breaking of chemical bonds. In a future lesson, I will focus on the making of chemical bonds. For this lesson, the following components are really helpful to have. You are seeing here a clear ramp, which is basically a PVC pipe cut in two. You see a speedometer, similar to this one. You also notice a clear plastic beaker at the end that kind of keeps all the components contained. Chemistry textbooks are also useful to get the right elevation. You will need a metallic marble, as well as a non-metallic marble, and magnets of different strengths. And then, of course, you need a high school class of chemistry students to conduct the actual experiment. When did I complete this lesson? I conducted this lesson during marking period 1. It took me up to 2 class or lab periods of roughly 50 minutes each. The top video shows you how the non-metallic marble is being rolled down the ramp so as to determine its speed. The bottom video is very similar, but now at the end of the ramp is a magnet connected to a metallic marble. The magnet is relatively weak in terms of its strength. And again, the speedometer is now evaluating how much the non-metallic marble is slowed down upon breaking of this connection between the metallic marble and the magnet. Notice that there's only one chemistry textbook present, and that is enough of an elevation to break this magnetic bond. This set of videos is very similar from the one before. However, now we have a total of 9 chemistry textbooks. Better check my count to ensure that the connection between the metal and the much stronger magnet is broken. Again, we have here now a bigger plastic cup demonstrating a stronger magnet connecting to the exact same size metallic marble that we wish to interrupt with a non-metallic marble rolling down the ramp. This particular slide shows you the sets of data that my students collected. They did this threefold. Again, we have a smaller size magnet of roughly 1 gram and a much larger neodymium magnet of roughly 6 grams. This data shows you the net non-metallic marble speed. The required speed is of course much larger when the connection between the metallic marble and the much larger magnet is stronger. Taking the average of these 2 data sets of 3 trials, it clearly shows you that the greater the magnetic force, the greater the required speed to break that bond between the metallic marble and the stronger magnet. And my students plotted this data in Google Sheets, showing the 3 sets of data for the smaller magnet size, as well as the larger magnet size, showing you that direct relationship. To really drive this message home, I gave my students the following job after they completed this modeling activity. And the question that they received was the following: justify why the following diagrams are in order of increasing strength. The first set of diagrams simply reflects the GIF animation of the activity they just completed. And you're seeing here already that it's in the correct order. The greater number of books required, the greater the strength of the connection between the metallic marble and the magnet, as depicted by the larger bicep curl. Similar here. The first set shows you a connection between sodium and chloride ions, each only one value in charge, sodium 1 plus versus chloride 1 minus. There's a stronger ionic bond connection if it's between magnesium and sulfide, because magnesium has a 2 plus ionic strength versus sulfide a 2 minus. The stronger the charge, presumably the stronger the ionic bond. Now, to put this at the atomic particle level, you can see here in the left diagram, we have much weaker bonds connecting these homonuclear diatomic molecules. So it requires less thermal energy to break these bonds. However, if the bonds between these homonuclear diatomic molecules are larger, it requires more energy to break them. And so here you're seeing several photos of how my students organize these different pictures according to increasing strength. Same idea, as you travel from left to right, the bond strength increases. Stronger magnet, more books, higher ionic charge. Same idea, weak magnet, strong magnet. 1 book, 9 books. 1 plus, 1 minus charge, 2 plus, 2 minus charge. To complete this lesson 5, I then ask my students to actually write a statement, justify in terms of ionic charge why the bond strength between these pairs of ions is increasing. And depending on the level of your chemistry class, you can either focus just on the charge, or you can also bring in the size of the atom. But what about melting point? Now justify in terms of melting point why the bond strength between these pairs of ions is increasing. So we've now reached the end of lesson 5. Are magnets a good model for the connection between particles? By having your students model the breaking of chemical bonds using the clear ramp, the metallic and non-metallic marbles, and the speedometer, you can really have them think about all these connections at the particle level. And then you can further enhance this lesson by having them think about the justification between the various charges of cation versus anions and their connection, as well as the melting point of various binary ionic compounds. Why are storylines so powerful? They are a verhaallijn, a storyline. It's like the red thread, de rode draad, that connects all these different lessons to one another. They follow a perhaps more logical flow between the various labs and activities. Again, we're following the next-gen science standards both for matter and its interactions and for energy in components of a system. You want these lessons and their keys? Again, check the link in the video description below. In exchange for your email, you will get the following Google Doc with all the respective keys and lesson plans and associated YouTube videos. I also have accumulated a kit, so the various components can be found in that same Google Doc. It takes you to an Amazon store link where you can purchase these individual components. Stay tuned for lesson 6, where we're thinking about, are all bonds the same? Thank you very much for watching. Bedankt voor het kijken. Tot ziens and see you in the next video.